your inductance values are less than the critical and your current is discontinuous, so during this discontinuous conduction mode, we have seen that the value of the output voltage is going to be d times of Vs upon beta. Now, in order to know how much is the value of beta, which will let us calculate the output voltage, we try to utilize the average value of inductance expression. Now, how much will be the average value of inductance? If you look at that average value of inductance, then the inductance current, the average value of, in order to know the value of beta, which will let us calculate the output voltage in this case, we try to utilize the average value of current flowing through the inductor. Now, how much will be the average value of current flowing through the inductor? That if you see, the average value of inductor current is going to be exactly same as average value of output voltage. Because the average value of current flowing through a capacitor is 0. So what we mean to say is the value of IL average will be exactly same as I naught average. So if you know the output voltage and output currents, then output current is nothing but the average value of your inductor current. So will it be changing from continuous to discontinuous? You can say that with the variation in the inductance values, your ripple is changing, but the value of the average current remains same. So though you have a higher value of current ripple, though your current is discontinuous, you can understand that your average value will remain same, and that average value of the inductor current will be same as your output average value of the current. So now if you try to get the expression for the average value of inductor current, you can see that your IL average value is over a period of time, that is 1 upon T integral 0 to T IL of T dt. So this is what we have. And now if you wanted to get that, substitute the values of inductor current and integrate with respect to that. It is 1 upon T. What is average is basically this is area under that inductor current. If you want to get area under that inductor current, it is perfectly a triangle. Now you know what is the base of the triangle, you know what is the height of the triangle. You can simply use half base is beta T, height is I max. This is what is an expression for IL average value. Now you know that this will be exactly equal to I naught average value. So if you can use this relationship where you know what is the maximum value of the current that you can get it, and also the I naught average and I max and time, then you'll be able to get what is the value of the beta. Now from this expression of the average current through the inductor, which is exactly same as I naught average, if you substitute the maximum current expression that we get in the previous cases, then we'll be able to get what is the value of beta. Value of I max can be expressed as Vs minus V naught upon the value of inductance multiplied by dt. This is the expression for the maximum current. Now you can write down that value of V naught is d in times of Vs upon the value of beta. So if you substitute all of it, it is beta by 2, because this time and this time will get cancelled. Then it will be beta by 2 I max, whereas I max is Vs minus d by beta times of Vs upon the value of inductance multiplied by dt is I naught average. Provided that you know average value of the output voltage, output current, provided that you know the average value of the output current, then you will be able to calculate what is the value of beta. So beta can be calculated from here. So once you know the value of beta, then you will be able to calculate the output voltage as d minus d times of Vs upon beta. So that's how we'll be able to calculate the output voltage here.